For our last section in this chapter, we're going to look at counting and probability. Okay. So the first topic is counting and tree diagrams. So there's this thing called counting and probability. You need to have a fairly good understanding of it. So we're going to start really simple with tree diagrams, which let me say this, we start really simple with really simple examples using tree diagrams because a tree diagram can get really big really fast. So we'll just kind of understand the idea, and then that's going to lead us to something called the fundamental counting principle, which is going to make it a little bit easier. So just bear with me for topic one. Topic two, we're going to kind of find like a shortcut for this. Okay. So counting and tree diagrams, definitions. Love a good definition. So counting, I don't have the C in bold. I just noticed that. So counting refers to the technique used to determine the number of possible outcomes or arrangements in different situations. So you kind of have different things that you're mixing together. We're going to look at outfits and then we're going to look at Happy Meals at McDonald's. How many different ways could you create an outfit based on different individual pieces of the outfit? How many different ways could you build or order Happy Meals based on the different components of a Happy Meal? Okay, so that's what counting is. Now, a tree diagram is a tree diagram is a graphical representation used to illustrate all possible outcomes of a sequence of events or decisions. Okay, so a tree diagram, it's not really a graph, but it's a very visual way to understand and come to this conclusion about how many ways could we do something. Okay, so example one says draw a tree diagram for each scenario. Okay, so part A says suppose you have four shirts, white, gray, blue, green, three pairs of pants, jeans, khakis, and then some kind of black pair of pants. How many different outfits can you create? Well, for each shirt, you could match it with each pair of pants. So what is that going to look like? Okay, you can do this vertically or horizontally, it doesn't matter. We're going to start with the shirts. So I'm going to use just W for white, G for gray, B for blue, G for green. Okay, ooh, we've got two grays. We'll do GR for green and then just G for gray. Okay, dang it, that's not going to really work either. We're just going to spell out gray and then we're going to leave it just G for green. They both start with GR, so that was kind of stupid on my part. I should have picked a different color. Okay, so we've got our four shirts, white, gray, blue, and then green. Okay, now for each shirt, we could match it with each of the three pairs of pants. So for the first shirt, the white shirt, we could match it with jeans, khakis, or the black pants. For the gray shirt, we could match it with jeans, khakis, or the black pants. For the blue shirt, we could match it with jeans, khakis, or the black pants. And then for the green shirt, we could match it with jeans, khakis, or the black pants. This bottom row represents how many different outfits that we could create with this. So we could have white with jeans, white with khakis, white with black pants. We could have gray with jeans, gray with khakis, gray with black pants, and so forth. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 different outfits. So 12 different shirt pants combos that we could create. Now, you can see how a tree diagram can get kind of dicey. What if we added shoes to the mix? What if we said, okay, we have two different pairs of shoes, five different pairs of socks, 12 different pairs of underpants? This could get gigantic really, really fast. So a tree diagram is really awesome. It's super visual, but it's not always going to be the most realistic depending on how many items we're looking at. Okay? Now, for part B, it says at McDonald's, you can get a Happy Meal with chicken nuggets, a hamburger, or a cheeseburger. For the side item, you can choose between fries or apples. Now, I could have added drinks, but again, it gets complicated the more items you're looking at. So if we were looking at the main item, the side item, and the drink, it could get really big. But for this, we have chicken nuggets, a hamburger, or a cheeseburger. So we're going to use CN for chicken nuggets. Also, I was at Chick-fil-A one time. This is the funniest thing ever. I was at Chick-fil-A and this woman was ordering in front of me. This is the one that used to be across from the mall where you had to like walk up to it. It didn't have the drive-through. So I'm standing outside, probably burning my buns off because it was probably like 1,000 degrees outside. And this woman asked for the 8 count chicken McNugget meal, and I thought I was going to die. I was like, sweetie, you are not at McDonald's, you're at Chick-fil-A, but that's besides the point. Anyway, so we have chicken nuggets, just a regular hamburger, and then we have a cheeseburger. With the chicken nuggets, we could get apples or fries. With the hamburger, we could get apples or fries. With the cheeseburger, we could get apples or fries. So, how many different Happy Meals could we order? Well, one, two, three, four, five, six. So, 6 different Happy Meals could be ordered. But just for fun, let's say we incorporated drinks. Okay, so what if we add a beverage? And let's say our beverages are milk or soda. Okay, so if we had milk or soda added to the mix, that's going to change the number of meals that we could order because we could have a chicken nugget apple meal, but then that could be with milk or with soda. So we would go milk or soda, 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 and finally milk or soda. So now when we add either milk or soda to these meals, so there were 2 ways that we could order chicken nuggets. We could order chicken nuggets with apples or chicken nuggets with fries. But now we've added this extra layer of either milk or a soda. So let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 meals are possible if we include drinks. So those are tree diagrams. They're not hard to create. They're just a little tedious. And again, it all depends on how many items we're looking at and how many options you have for each item. Okay. So there you have it. That is counting and the tree diagram. In the next video, we're going to kind of look back at these tree diagrams and we're going to see if we can find an easier way to do this. And that's going to be called the fundamental counting principle. Okay. And if you're ever at Chick-fil-A, please don't order McNuggets. Just order plain old nuggets. Okay. McNuggets are specific to McDonald's.